Welcome to this short video on Introduction to Chaos Engineering. What is chaos engineering? Chaos engineering is the discipline of experimenting on a system to build confidence in its ability to withstand turbulent and unexpected conditions in production. It involves deliberately introducing failures or adverse conditions into a system in a controlled manner to identify vulnerabilities, improve resilience, and ensure reliability. The core idea is to simulate real-world failures before they happen to minimize the potential impact on end users. Chaos engineering often includes practices like 1. Fault injection. Fault injection is a testing technique that deliberately introduces errors or failures into a system to evaluate its behavior and resilience. By simulating real-world issues, such as hardware malfunctions or software bugs, fault injection helps identify vulnerabilities and ensure systems can recover gracefully. It is a key practice in improving reliability and fault tolerance in critical applications. 2. Simulating latency. Simulating latency is the process of intentionally introducing delays in a system to test its performance and behavior under slower response times. This technique helps evaluate how well a system handles network or processing delays, ensuring it remains reliable and responsive even in less than ideal conditions. It's commonly used in performance testing and to identify potential bottlenecks in distributed systems. 3. Testing failover mechanisms. Testing failover mechanisms involves evaluating a system's ability to automatically switch to a backup or redundant component in the event of a failure. This ensures that critical services continue running smoothly even when primary systems experience issues. By simulating failures and testing failover responses, organizations can validate the reliability and effectiveness of their disaster recovery plans and minimize downtime. Imagine a system. It could be a website, an app, or even an entire cloud service. This system has multiple parts working together, like a team. There are servers that store data, networks that transfer information, and applications that respond to your clicks and taps. Now, in a perfect world, everything works seamlessly. But we know the real world is full of surprises, like sudden power outages, hardware failures, or even a curious cat unplugging a cable. These disruptions can cause parts of the system to break down. Chaos engineering helps us prepare for those surprises by creating controlled experiments, where we intentionally introduce disruptions to see how the system reacts. Sounds wild, right? But here's the key: it's all done in a safe and thoughtful way, using tools and strategies designed to minimize risks. Here's how chaos engineering typically works. Step 1. Define a steady state. First, we need to understand what normal looks like for the system. This could be things like how fast a website loads, how quickly an app responds, or how many transactions can be processed in a minute. Step 2. Create a hypothesis. Hypothesis is a Python-based testing framework designed to create property-based tests. Unlike traditional testing, where specific inputs and expected outputs are manually defined, hypothesis generates a wide range of test cases automatically based on the properties or rules defined by the developer. This helps uncover edge cases and ensures code robustness by testing with inputs you might not have considered. It's widely used for scenarios like data validation, algorithm testing, and ensuring reliability in complex systems. Step 3. Introduce chaos. Introduce chaos is a resilience testing approach that deliberately injects failures or unpredictable conditions into a system to identify weaknesses and improve its robustness. By simulating real-world disruptions, such as server crashes or network issues, it ensures the system can withstand unexpected challenges and continue to operate effectively. This method is commonly used in cloud-native and distributed systems to enhance fault tolerance and reliability. Step 4. Observe and learn. Observe and learn is a methodical approach to understanding systems or processes by closely monitoring their behavior and outcomes. By gathering insights from real-world operations, it helps identify patterns, areas for improvement, and potential innovations. This approach fosters continuous improvement and informed decision-making, making it valuable in fields like software development, business strategy, and education. Why is chaos engineering important? Chaos engineering is essential for building resilient systems by proactively identifying and addressing weaknesses before they lead to failures. It helps organizations ensure reliability, improve customer experience, and minimize downtime by simulating real-world disruptions. By uncovering vulnerabilities in controlled environments, chaos engineering enables teams to design systems that can withstand unexpected challenges, making it a critical practice for modern, distributed systems. In today's world, we rely on technology for everything like shopping, working, even staying connected with loved ones. A small glitch in a system can lead to big disruptions, lost revenue, and frustrated users. Chaos engineering helps businesses build confidence in their systems. It's like running fire drills for technology. The more prepared we are for the unexpected, the smoother things will run when challenges arise. Here are some real-world examples. An online retailer might test what happens if their servers get overloaded during a Black Friday sale. A video streaming service might simulate a sudden spike in viewers during a big live event. A banking app could test how it handles network delays to ensure transactions still go through smoothly. Each of these scenarios helps engineers find and fix weak points before they affect real users. To make chaos experiments easier, there are tools specifically designed for this purpose. 1. Gremlin, a platform that helps run chaos experiments in a controlled manner. 2. Chaos Monkey, a tool from Netflix's Simian Army that randomly terminates instances in production to test system resilience. 3. Litmus, a Kubernetes native framework for running chaos experiments in cloud-native applications. 4. Chaos Toolkit, a free, open-source toolkit for running and automating chaos engineering experiments. Getting started with chaos engineering. If you're curious about chaos engineering, the good news is you don't need to start big. Begin with small, low-risk experiments, like testing how one part of your system behaves under minor stress. Remember, the goal isn't to break things, it's to learn how to build better, more resilient systems. Benefits of chaos engineering. 1. Improved resilience. This refers to enhancing a system's ability to withstand and recover from disruptions or failures. By identifying vulnerabilities and implementing safeguards, resilience ensures consistent performance even under adverse conditions. This is crucial for maintaining reliability, minimizing downtime, and providing seamless user experiences in critical systems and applications. 2. Enhanced observability. This is the ability to gain deeper insights into a system's internal states and behaviors by collecting and analyzing metrics, logs, and traces. It enables teams to detect, diagnose, and resolve issues more effectively, ensuring optimal performance and reliability. Enhanced observability is critical for understanding complex systems, identifying anomalies, and improving overall system health. 3. Preparedness for real failures. This is the practice of proactively equipping systems and teams to handle unexpected disruptions effectively. By simulating potential failures and developing response strategies, organizations can minimize downtime, maintain reliability, and ensure quick recovery. This readiness is crucial for mitigating risks and maintaining trust in critical systems during real-world challenges. In conclusion, chaos engineering might sound like an intimidating concept, but it's really about building confidence. It's about knowing your systems are strong enough to handle whatever the world throws at them. Because in the end, it's not just about preventing failures, it's about delivering trust and reliability to the people who depend on you. Please click the link in the description to access this lesson on Motiva Logic Academy Learning Management System, where you'll find a quiz for every lesson, hands-on lab and projects to test and strengthen your understanding. While you're there, explore the full catalog of advanced hands-on courses and downloadable resources designed to help you move from theory to real-world expertise faster. Be sure to like, subscribe, share and visit the link in the description. Don't forget to turn on notifications so you don't miss the future lessons. Thanks for watching.